Are you there? Somebody get the Ouija board out. All right. So what I want to try and do today is we're going to go through about maybe 2.5 sections. I wrote down that we're going to try and get through sections 2. It's actually 2.2, 2.3, and 2.4. I accidentally wrote 2.1 on there. We're going to do 2.2, 2.3, 2.4, which means we're probably going to get through 2.2 and 2.3. No big deal. What's nice about these first few sections is that it brings back a lot of old memories of slope-intercept form and finding slopes and all that kind of fun stuff. But what I want to do is just start with slopes. What is slope? It is rise over run. All right? Slope, rise over run. What values rise? Y values. What values have the runs? Oh, that's great. So we write it as change in Y over the change in X. I'm assuming that all of you guys know that the Greek letter delta stands for change. And basically when you're looking at it in terms of like a math values, you're looking at sets of ordered pairs. And if we're looking at sets of ordered pairs, you have 2 of them. First set of ordered pairs, second set of ordered pairs. Do you know what those numbers mean? These subscript. Yeah, thanks. It just says what they meant.
Yeah.
It means x sub 1, x sub 2, y sub 1, y sub 2. All that means is just first set, second set. Doesn't matter. Obviously, the first x has to put the first y. Otherwise, bad things happen. Cats and dogs living together, complete pandemonium. And we just write it like this. What letter do we associate with slope? M. Do we know why we don't use, well, why don't we use the letter S? So it looks like a 5. Why don't we use L? Or L for line. What about O? It's a 0. What about P? 9? Yeah. P stands for perimeter or probability. E.
Electricity.
It's actually an exponential function, like principal or e to the RT, that one. All right, so then think about your other letters. Why don't they use A, B, and C?
Those are used.
Standard form Pythagorean theorem, okay. What about D? Distance, diameter. E we just talked about. What about F? F of X, it's function. It's called function notation. Same thing with G and H. F, G, and H are generally associated with function notation, and we will do function notation eventually. Ish. Do you know why we don't use I?
Imaginary.
It's imaginary. You can think about using it, but you can't use it. Or can you use it because you're thinking about using it?
No.
It's there, but it's not there.
That's an imagination. So,
Okay. What about J? There's a reason why we don't use J. There is. There's something later on in chapter that talks about something called joint variation. Joint variation is like direct. You know what direct variation is?
No.
X varies directly as Y. It's called slope. Joint variation is when you have multiple values of things being multiplied together for some sort of variance. K, excuse me. K was what? Also, potassium. Thank you. That's what somebody else said too earlier. He said nerd. And that gets us back to L, and then line, and then M was the next available letter. Math people are weird.
Math. We don't use M because of math.
No, they use M because of slope. Because they went through all the rest of the alphabet and there was nothing left for them to use. So they got to M. N is number. O looks like that. P, Q is quotient. R is radius. S, and so on and so on and so on. I just made all that up.
was the trigger.
That, you remember the whole 80-20 thing?
Ours,
That's the 20 thing. But I don't like to worry so much about just plain old slope. I want to know, how do I find it? Well, it's nothing more than a fraction. Okay. This question came up earlier today about with negatives and things. Well, let's write this first. If I wanted to find the slope of this, and I know this is super, super fast. What we're looking at doing here is basically, excuse me, just fill it in the blanks. If you had forgotten the equation to solve for slope, just write it down.
Oh, yeah.
All right. Write it down a couple of times and you'll be all right. Change in y, change in x. And what's nice is that with your calculator, you can just put all those numbers in the calculator and never be wrong, or take a chance and hopefully your brain is working correctly at that point in time. Now, do you remember the button that tells you how to create a fraction bar?
No, math.
Math button. Oh, there's a shortcut. Remember what's the shortcut?
No. Oh, that's
Like math.
Alpha y equals, right? It was close. Alpha y equals gets you to that fraction bar, and basically all you have to do then is just type in what you have. Yeah, so let's see, one. Do you guys know where the negative button is on this calculator?
Yeah, it's right there, bottom right.
What was it, 2 minus negative 3?
2 plus 1.
Now this question came up earlier. When you have a fraction that winds up being negative, when you have a fraction that winds up being negative, what's negative, the 4 or 5?
4.
Does it matter?
It doesn't matter.
No, because what direction does a negative slope go? Down and what? Down and right. A negative slope goes down and right, which means that you went down 4, right 5. Now, isn't that the same thing as saying up and left? Up 4, negative 5 to the left then?
Okay.
Usually speaking, we designate whatever is the negative value as the top number. Because when I work with slopes, we do the rise before you run. You're going to walk up and down the ladder. And that way you know you're either going up or down, and you're always moving to the right. That's one way that I do things. If you do something different, whatever, it doesn't matter. Okay? Yeah, doesn't matter anyway. As long as you get it right, I'm fine. Slopes. How many types are there? Many. More. We have 4. Anybody else? Too many.
I just saw the next. I saw that on the side, so.
So yes, you were paying attention. Congratulations. There are 4 types of slopes. What are they?
That one.
That one. We have
The other one.
we have a negative slope.
A
Then
positive
like slope.
A mutual slope. I
And
don't
then
know.
horizontal.
Mutual.
Vertical.
So we have a negative slope, which goes this way. We have a positive slope.
Horizontal.
Okay. You have a horizontal and vertical lines. Now, what is the slope of every single horizontal line?
0.
Very good. You know why that is?
Because it's not going down.
What's the second letter in the word horizontal? Oh. Slope of 0 is because it's a horizontal line. All right. And then what's the slope of every vertical line?
Infinity.
No. It's undefined. Very good. Here's someone say it. Slope of every vertical line is undefined. The reason why it's undefined is because if the value of x is staying constant, that means it never changes. So if your value of x in a slope equation is 3, what's 3 minus 3 always going to be?
0.
Can you ever divide by 0? No. That's why you get an undefined slope. Okay. Another thing to remind yourselves of, horizontal lines always have the exact same equation. Horizontal lines will always have the exact same equation. Only one small thing changes. What was the equation of every single horizontal line?
Y equals.
Y equals what?
B.
8. Okay.
Every
Oh.
single one.
Y equals B. And you're right, because what is B?
The y-intercept.
So basically that B value is always going to be some number. Good. So the equation of every single horizontal line is always y equals a number. That number is the y-intercept. Whatever the value of y is, that's where the equation goes. On the other hand, then, what is the equation then going to be of every single vertical line?
X equals
A number. Good. X equals some number. And this is kind of a weird thing for people to remember because I don't know why. The reason that I wanted to show you that is because, well, I thought we'd have time for it today, but I know we won't, is when we start talking about parallel and perpendicular. What do we know about parallel lines in regard to their slopes?
They're the same.
They're always the same. Okay. What do you know about perpendicular lines? Opposite. What does that mean when you do this?
Opposite inverse.
Reciprocals. Okay. Opposite reciprocals, slopes. Now, if you look at your, steal yours because he's not taking notes, he's a slacker. When you look at your paper, the blue lines are all horizontal, aren't they?
Yeah.
The red lines are vertical. Aren't they perpendicular to one another?
I believe so.
Now, if I do this, my blue lines are now, and my red lines are they still perpendicular?
Yeah.
Whoa.
Yeah.
Are they still perpendicular?
Changing the graphs, not changing the line.
Exactly. You all right?
The same concept.
Over
Like,
exuberance
just-
of the head bob is just kind of funny. Because that's just, because you're making your hair bounce and you're thinking it's funny. You're like, not that I've embarrassed you. It's okay. You all right?
Yes.
Bit much. You go up to Minocqua all the time?
What?
Does your shirt say Minocqua? I thought it said.
No.
Oh. Oh, from here it looked like Aqua.
Like, awful man.
Yes. Good conversation. Anyway, math, right. So we have parallel, remember this symbol?
Yes.
Yeah.
Okay.
Did not even touch it.
What's that?
Did not even touch it.
They don't need to be touching, do they?
Yes.
Now,
Well, if they're second,
when you get into it then, as you start going further, if you have like a generic slope, for example, and we're going to eventually get to more of this stuff. If my original slope is, I don't know, 2/3, what's parallel to that? 2/3. Parallel to that would be 2/3. Perpendicular to that would be
Negative 3/2.
-3/2. Good. If my original slope is undefined, what's parallel to undefined?
0.
Undefined.
Oh.
Remember, undefined slopes are vertical lines. What's parallel to every vertical line?
Oh, fair.
Other vertical lines, which therefore have slopes of undefined. That's why I take a minute and I write this out, this portion here with the horizontal and vertical and what all that means. Because if you remember it in terms of that, a lot of times you won't make the stupid mistake, oh, it's parallel to 0. No, it's not.
We just made the mistakes.
Yeah, if you stop making stupid mistakes, you'd be,
Fine.
fine. So parallel is undefined, and then perpendicular would equal 0. And that was something you guys spent a boatload of time on in Algebra 1. I don't know, did they do a lot of that in geometry? I think you did a little writing equations and lines in geometry, but not much, right?
A little bit.
Just a little bit here or there.
Yeah. We did distance formula, we did slope.
This is from it's just Pythagorean theorem.
Yeah, he said.
Yep, it's much easier that way. Just count. Rise over. You're fighting the slopes. Rise and runs and you square it and get the distance. It's crazy. No. Nope. 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 Nope.
14.
But I want to solve for the missing value. So a lot of times what we'll do, instead of just, here's two ordered pairs, find the slope. That's too easy. So what I'm going to do is give you a slope, find the missing value, which basically just works out to be a simple, straightforward equation. Now, suggestion. When you're doing stuff like this, I know it takes, a minute or so longer, but if you write down the actual formula to start with, then just fill in the blanks. It forces you to, well, first of all, slow down, because you guys have a tendency of going way too fast in some of these things, and it helps avoid that dumb mistake. And then it also helps you to reemphasize where place value and things like that go. Okay. Now, starting to, I just write down the equation for slope. Change in y, or change in x, and I fill in the blanks. According to this, my slope is
-1.
-1. And then I have, what is that, 8 minus 4, -6 minus x. Now, do I change anything by doing that? No, not at all. If I put that value over 1, it does not change the value of -1 at all. But what it does create is fraction equal fraction. When you have fraction equal fraction, how do you solve? Yeah, cross multiply, exactly. It sets you up to cross multiply. You don't have to put it over 1, but a lot of times when I do that, it reminds students that, oh, this is just a cross multiply problem. And once you see that, like, much easier. So cross multiply through, obviously when you cross multiply the 1 this way, it doesn't change anything, so I can just say that that side is equal to 4. And then the other side is -1 times the quantity -6 minus x. What are you going to screw up? You'll forget to distribute this second negative. Happens all the time. Happens all the time. So we have 4 is 6 plus something. The something is? -2. Very good. I just wanted to take a second and show you how to solve something. Okay. Not too bad? All right, anyway. This one, 1. That's 2.4. I need 2.3. Oh, I don't have it open.
Oh yeah, you just record all this, doesn't you?
What's that?
We're gonna make a best of Murphy compilation at the end of the year. Just all of the jokes that you make is from
Oh
that.
God, that's gonna be awful. People will pay you not to play it.
Exactly.
Or you're doing the editing, right?
Yeah, I wouldn't want to go through that tape. You have to start marking right now about approximate times and things that something funny happens. I notice you haven't marked anything down yet.
You would just have to watch the entire film.
No.
Every lesson.
Quick graphing. You guys were never taught this. Kind of a shame. Quick graphing is awesome. But I want to start with just for a quick reminder, what is slope-intercept form? Slope-intercept form is?
Y equals mx plus b.
Y equals mx plus b. Good. The reason why we taught you guys slope-intercept form over and over and over again to make sure you put things into slope-intercept form is because eventually we knew that you would get a calculator that has a button on it that says
Y equals.
y equals. Okay. So once we got to the point that of using that, it's also a little bit quicker and easier to use with systems if you have to do substitutions and stuff. But y equals mx plus b, obviously m is your slope, b is your y-intercept. It's very useful. It's super easy to create tables. It's super easy to graph off of. Not a big deal. The one that tends to be left out a lot of times is this thing called standard form.
AX plus BX was
AX plus
equal to C.
BY equals C. This one, we beat you guys over the head with a ton of rules, if you recall.
Yeah.
If you remember that the rules were like A and B both can't equal 0, the GCF had to equal 1. There's a whole slew of stupid things that you had to do. Well, now, I don't care. Because if you can get it into this standard form where it's AX plus BY equals C, you can do something that's super, super easy. For example, if I just put a grid up here and ask, if I'm graphing something, what's the value of y when I cross the x-axis? 0. What's the value of x when I cross the y-axis? 0. So here I know that it's going to be some ordered pair x comma 0. Here it's going to be some ordered pair 0 comma y. What are those two things called? Don't overthink it. You know this. The y-intercept and the x-intercept. So what I can do here is that if I substitute values of 0 for x, I can find my y-intercept. If I substitute zeros for y, I can get my x-intercept. Because how many points do you need to make a line? Two. So here's what happens. If I do that where something simple, let's say 2x plus 3y is 6. And I wanted to plot this. All I have to do is take if I cover up the x value, what's my y-intercept? 2. If I cover up my y value, what's my x-intercept?
Is it minus 3 BY?
Whoop.
That's not important. This is for the notes.
For what? For minus 3y?
Is it minus or plus 3?
Oh, I'm sorry, this was a plus 3y. If it was a minus 3y, my intercept would have been at negative 2. Because when you solve it out, you would divide it out by negative 3. Does that make sense?
Yeah.
So here I have 2x. What's my x-intercept then? 3. Connect the dots. La 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 la. Quick graphs. Graphing via intercepts. From what I've known throughout the years is that most people never learned that. I'm sorry, but you can use it whenever you want. What's that? It is. And the important reason that I show you guys this is that eventually, in a couple of weeks when we have linear inequalities, we're going to graph things via intercepts. And then we're going to have to shade on either side of a graph. Well, there's no reason at all to go through and try and put things into slope-intercept form and plot it via, walking your slopes and doing all that. It is so much more time efficient and much easier to quickly visualize a graph, because I don't like graph paper, to do it like that. That's all you got to do. Plus, we're going to have, when we start looking at these in terms of cost functions, we might have cost functions with intercepts of 120 and negative 6. You don't want to put all that in graph paper. You just say, oh, 120 is all the way out here on the right, negative 6 is just a little bit here on the left. And that's it. It's just a quick visual representation of a graph. Does that make sense? Much easier than you guys probably ever thought. Yes, sir?
Why don't we learn this earlier?
I don't know. I think part of it is because they want you to go through the process of understanding where all this comes from. I mean, even with this, when you have standard form, what's your slope going to be? How do you find your slope on this one? Think about it. Think about what you would have to do if you are in standard form and you had to get, what value would you have to get by itself to determine slope? You'd have to get y by itself, wouldn't you? So basically, you'd have to move the ax, which means how would you move a positive ax? Subtract it, and then how would you undo multiplying by b?
Divide.
Divide. So from standard form, you can always get your slope by taking the opposite of a over b. That will always be your slope. Standard form is really useful. It's kind of nice. But back, when you first look at this stuff, usually I think around 7th grade maybe, in Algebra 1 I think they start talking about this, maybe a little bit of pre-algebra there. There's really no need to get that crazy with it to get you in there. Because they still want you guys to start working about the idea of moving value and getting into that slope-intercept idea, because there's a little bit more algebra through it. Here we're starting to do a little bit more of the shortcuts. That's kind of what we do. Okay. Let's try it. I'm not in the right file anymore. What the heck? There we go. We did this, we did that. Nope. All right. No graph paper. Make it go away.
Yay.
Graphing. Take a second. Just plot a visual representation of what it would look like. Okay, take a second. Plot it via the intercepts. Okay. Being able to utilize intercepts just makes math quicker. Keep fancy pants.
It's quick graph.
That's what it is. And the idea that I'm showing you this now is because when we start doing stuff like this where it's going to be greater than, what the graph does, it actually cuts something into what's called a half plane. One part of the plane is on one side of the graph, the other part of the plane is on the other, and you have to know which side to shade. You're shading linear equations. It sounds weird, but it's really easy. Okay, but it starts with quick graphs. Okay. It starts with quick graphs. So if we plot this through, cover up the x value, what's your y-intercept? It's going to be at 4. So y-intercept at 4, so that ordered pair is at 0 and 4. The other one is, the x-intercept is going to be at 6. 6 and 0. Yeah, right. They all kind of do, don't they? That's it. Will it change if one of the values is negative? Nope.
Yeah.
Your graph will change, but the process never changes. I mean, the process doesn't change. 3x minus 2y is 6. Instead of dividing by positive 2, you're divided by negative 2. It just moves the graph. Which one? Oh, for the one before?
No, the one right now.
Oh, I haven't done it yet.
Oh,
What?
flip back a page. I was writing down the page.
Yeah, she just asked real quick about seeing the other one real fast. Sorry, I didn't. I get too fast. I get going too quick, and I just. You all right? Sorry.
That, there we go.
Start with your cheesy grid. Yeah, it's very, very rare that I'm ever have you guys use graph paper because there's no reason to. Well, absolute value will probably use graph paper because it's a little bit, and maybe step functions, but other than that, that probably will be the only time that we use graph paper. Most of the things we do is that you're going to scale it yourself and draw it out, whether it's trig or exponential functions, logarithmic functions, any of those things, because it's just a matter of ordered pairs that you're finding that are really quick to get. Where's your x-intercept on this one?
3.
X-intercept.
2.
2. X-intercept at 2, 0. Y-intercept at positive or negative 3?
Negative.
Negative 3. There you go. Quick graphs. Quick graphs are your friend. There's somebody that'll listen to your sadness or your happiness? I got nothing. Okay. I don't need you to do this. This is boring, 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 boring. Okay. I'm only gonna do a little bit of this, and then we'll call it a day.
What's the last word?
What's that?
What's the last word that's here?
Writing equations of lines. Sorry. Yeah, you don't have to really so much worry about a lot of these the titles. We don't spend as much time as we used to in some of these things. We find that a quick review of it is helpful enough. We don't need to go and spend a whole day on. Could you imagine spending a whole day on quick graphing? Just example after example after example. And wouldn't that just be dumb?
Yes.
Yes. So we get rid of some of the dumbness and kind of go a little bit quicker in parts, and we'll slow down later. That's just how we roll. Slope-intercept form we know is y equals mx plus b. Super useful. And usually what we do is when I ask you to write an equation of a line, I will ask you to write it into slope-intercept form because of the fact there is a y equals on it, and you can throw that in your calculator then. But sometimes you might not be able to do that right off the bat. That's why we use point slope form. Do you vaguely remember what point slope form looked like?
This is the one that I didn't
What's that?
like.
Here's a spoiler alert. There's a point and a slope in it.
Minus something equals
But that's the, I remember it, like for one equation, so it was really
Look.
good.
Yeah.
It came back.
It looks like that.
I knew it was really beautiful this way.
Okay. Point slope form. Point slope form is that y minus y sub 1 equals your slope times x minus x sub 1. This is a hugely useful formula. We use it a lot when you know a slope and an ordered pair. We use this when you have 2 points. If you've got 2 sets of points, you can find the slope, and then you can utilize one of those points to write the equation of the line within point slope form. That's something that we use a lot when it was writing the equation of the line that was parallel, write the equation of the line that was perpendicular, write the equation of the line that contained these 2 points, and so on and so on and so on. You'll use it a lot. Also, just so you will see this. What's the difference between those 2 equations?
What am I saying?
Yeah, and A.
Just to give you guys a little heads up, most graphs that we deal with have what's called a shift to them. Some horizontal, left and right, H, and some vertical, up and down, K. But A is kind of like an amplitude. It's linear in this case, which means that's kind of like its slope. What happens here is that you're going to see these H and K values. H and K is nothing more than an X and a Y value. We use H and K for shifting functions a lot. Point slope form was a shifted equation of slope-intercept. You just didn't know it. What's that? They are the same equation. They really are. Because what happens is it's y minus k is a x minus h, which is the same thing as all that other stuff. Don't worry about this quite yet, but it's just kind of like a little, in a month or two when you start seeing more AHs and Ks, you're like, oh yeah, Murphy, I remember you said that like on the second day of school and I wasn't paying attention. I was doing my Spanish homework.
This was the 5th day of school.
So things like that. All right, just a little heads up on that. Questions about anything? I kind of flew through a lot of junk. How do I concentrate? Think really hard. Did you ask me how I concentrate? Really?
No, I said, how do you count?
How do I count?
You said this
Oh,
was
1,
the second day of
2,
school.
3.
Isn't it 1, 2,
You said
class?
this was the second day of school.
The second day of like actual math.
Okay.
2,
We'll give you that. We'll give you that. Right.
I've got that. There's a worksheet that I made of the a couple of sections out of the textbook. Sorry? Yeah, just some of it. Now, obviously we're not going to do, ladies and gentlemen, obviously we're not doing all of this. This is that worksheet that had the 2.3, 2.4 stuff on it. We're not going to get into 2.4. What I want us to look at is going to be that 2.3. Can you open that up? Oh, I don't have it? I can scan it. Thought I did. On this one here, all I'm asking you that you do is this middle chunk of the 13 through 21. The middle chunk of the 13 through 21 is asking you to find.
Missing 2 managed to undercount this time?
You got it? Thank you. Do you get it both? Thank you. What I'm basically having you do there is just find the intercepts. Obviously, some of the problems themselves, you have to move some things around to find the intercepts to put them into that standard form, that ax, by. But that just figures it's just good practice to be able to do that. You know, I mean, if you can find the intercepts, there's no reason to sit there and plot and graph. That's just kind of a waste of time, okay? Also, there are 2 problems on the very, very, very bottom that you're solving for that missing value of k. Yes, sir? Yeah, because I don't know how to count. So, get those through. Save the sheet because we'll do the equation jump that are on the other side tomorrow. All right? No, just those bozo.
I'm ready to go.
Oh, yay, thank you.
Let's see.
I don't have to do the first 12.
I was like, you don't want to go to eat. To become a doctor. I want to become a doctor. And I'm pretty sure I'd be very bad. Wouldn't have any insurance. I'd be the who's on maybe like cable. Trust me, but we killed 2 people.